Yes, we're at the top of the hour. Welcome. I see a lot more people streaming in, and thank you for joining from however far you're calling in from, and at whatever time that it is for you, whether it be the morning, lunch, evening. We're really excited to have our session today focused on commissioning ventilation systems. So Michael and Luis from Stephen Winter Associates sounds like mostly going to be covering centralized ERVs and HRVs, maybe a little bit discussion of heat pumps. And Zoe, do you want to introduce Michael and Luis?
It would be my absolute honor. Thank you, Carmel. Luis Aragon has worked as the commissioning authority for code compliant buildings and for passive house buildings. His responsibilities have included reviews of MEP, design drawings, sequences of operation, controls packages, and post-occupancy performance analysis. Luis also provides training for multifamily building operators on hydronic heating and domestic hot water distribution. Furthermore, he has experience performing testing to ensure quality installation of building envelope and central ventilation systems. And then we also have Michael Schmidt, who is a building systems consultant with a focus on performance testing, field inspections, and verification of energy efficacy measures on projects pursuing passive house certification. He consults with project teams throughout design and construction, with early involvement in plan reviews and later final testing to ensure actual performance meets design specifications. Very important. Michael is accredited in both Passive House US, SOPHIUS, and International PHI standards. And I will also just mention that I had the pleasure of working with Luis at Bright Power for a couple years. This was before Carmel arrived at Bright Power. And it was just an absolute pleasure. Not only is Luis a good friend, but he's one of those people who doesn't just want to do his job. He wants to ask all the questions and learn as much as possible. And we had a lot of fun doing that together, and he also taught me quite a bit about field verification. So I really appreciate that, and I appreciate both him and Michael being on our program and sharing from their perspective in commissioning and verification today. So without further ado, thank you both so much, and look forward to hearing it. Please take it away.
Yeah, thank you so much, Carmel and Zoe, for that warm introduction. We're happy to be coming from you live, New York City. It's noontime here. And we have a great slide deck here lined up for everyone. It's also good to see some familiar faces in the audience too. This has always been a great community to connect with, so happy to be here. I think just to preface the conversation a little bit, this is, we're deeming this the Tales from the Trenches, commissioning passive house ventilation systems. Now, really, what I want to start with is that we are still in the trenches on some of these issues. We're going to be presenting a lot of data that we found in the field, and also some great site photos, just to show you all some of the processes that we've been approaching large-scale multifamily buildings in the New York City region. And elsewhere. We might use ERV and HRV sort of interchangeably. We see both systems. We're not really focused on that. We're more focused on the actual implementation of them. Yes, so let's go to the next slide here. So, what are we really talking about today? This is a great schematic showing, our typical building layouts for multifamily passive house buildings here in the city. And really, there's a transition here to show that really the focus here is just on energy recovery ventilation, ERV, HRVs that are serving multiple floors, typically a central plant on the rooftop. We're exhausting our stale air from, the bathrooms and the kitchens, and we're supplying to living spaces and bathrooms. So I am coming to this conversation with the understanding that I hope most of the audience is also familiar with the basic concepts of ventilation strategies in passive house buildings. We're just applying this at a larger scale here. Another thing I just want to highlight on this slide is we're really building a very airtight building enclosure, right? And with that, we need to ensure that our ventilation systems are commissioned and operating properly. If they are not, we are really defeating a lot of the purposes of passive house and delivering better indoor air quality. If we're not able to control the air movement in the building and introduce that fresh air, we can wind up causing more issues than intended. So I think there's two certification issues with any passive house project. Me, from my verification standpoint, it's passing the whole building blower door test. Fortunately, we've had a very good track record of that, and I think most projects sort of have that down. I think the kind of less, I'll say, sexy part is on the ventilation side. Ventilation commissioning and the testing and balancing is can potentially be a hiccup when it comes to certifying to the passive house standard, whether that be international or the FIAS standard. So why is that, right? We actually have to verify the wattage of the fans in the ERV units, and we're verifying the final flow rates delivered to the building. And those are two modeling, energy modeling inputs that kind of add this additional step of verification. So you can go to the next slide here. So this is just a great schematic. There's a couple transitions we can walk through here. And I'm going to talk about the testing and balancing approach and our process and what we've worked on with many different TAB contractors in the region. And really, we're seeing a lot more large rooftop ERVs that have an integrated controller. This controller is actually, we found to be very accurate and informative to show the total flow rates that are actually being introduced to the ductwork system and into the building, right? So this unit is making its own flow rate measurements. We don't necessarily need to trust that. We're going to go to the balancer and ask them for a traverse reading in the main stem of the duct coming off the ERV. This is going to confirm that the controllers has some accuracy and that all the air that's pushed through the ventilation unit is actually making it into the ductwork system, right? Then the last part here is really on measuring and adjusting the flow rates within the apartments. Now, flow control has been sort of historically addressed, at least on our projects, using car dampers, a constant airflow regulator, a small plastic device that regulates airflow based on pressure. And those are installed at each air outlet. We might show a photo or something like that later, but really we're measuring and we're making those adjustments. We're having the balancer typically do this work. And then under the FIAS standard, as the passive house FIAS verifier, we have to come in and verify 10% of the flow rates in any of these structures. So, and that's a certification requirement, and they must match essentially the TAB report and show that we're meeting minimum exhaust flow rates and that the design intent has been truly implemented correctly. You'll see a photo here of me holding up a very specific calibrated device. It's a RetroTech unit. This is a low flow measurement unit that's designed to measure flow rates at this low rate. We can go to the next slide. I have a bit more detail on this. I think I could talk about it all I want, but this LB&L report said it best, in my opinion. I have highlighted some of the points here, and really, we've seen a lot of different capture hoods, flow capture hoods used on site. The unit shown here on the top is something they might use in a hospital. It's supposed to be very accurate, but what we found is when we're taking readings of incredibly low flow rates, 20 CFM, 15, 10 CFM, very low flow rates, these units are inadequate to measure flows at that rate. The photo here on the bottom, I hope you never see on your project. This is essentially a vane anemometer with a flow cone. This is about as inaccurate a device you can get. It's about a 50% accuracy when you're reading flow rates in apartments. So I think this sums it up well, is, really, if we aren't using, if we transition one more photo here, this essentially calibrated powered flow hood. This makes very, very detailed and specific adjustments here. We can see that it's reading 20.6 CFM in this case. They have an error of about 2 to 3%, which is about the best you can get, and is really needed to address things like duct leakage in a system, which happens to be very important in our passive house buildings, and as we're pushing towards high performance buildings across the board. Okay. Next slide. So, what has some of the experience been? This is a great example. I think we've gotten a tab report. We've seen a few of these in the past. The tab report looks perfect. They came into the building and every single flow rate that they measured matched the drawings perfectly. Now, in reality, of course, that's not the case. And unfortunately, this was a big hang up for this particular project. They didn't get certified because of this. We're still working on the project to actually balance it ourselves. We've been hired sort of as the balancer in this case, but that's not a typical role for us. And right when we get there, we're measuring flow rates that were supposed to be 15, and they're set. Their flow rate reading here was 27. We're also looking at the ERV controller, and we're seeing that it still has its factory default settings. So the controller was never touched. Nothing was actually adjusted or balanced. I'm not even sure if anyone walked into the building in this case. But this is something that we just need to do better on, and we're kind of bringing to everyone's attention as the realities that we've seen. Yes, so the falsified report. So of course now we're since then, this was quite a few years ago, we're pushing for third-party balancing firms that are certified, have a professional certification. Next slide.
Right, and so let's start talking about shop drawings, which is like perhaps one of the key phases where we can start pointing out key concerns, right? At the end of the job, we want to be able to have an as-built condition that looks similar to the design, but that's rarely the case. But there are some things that can be tried to achieve this. So yeah, let's talk about shop drawings, and I want to expand a little bit on Michael's mention of the traverse flow readings that need to be taken to verify the accuracy of that ERV controller that we typically see. So that's where the shop drawings phase takes the front and center position. So the commissioning agent in this case, in typical case for our projects, is myself with the passive house consultant, Mike Schmidt. We will review the shop drawings to look for a number of things, such as reroutings that can add pressure drop and could compromise the ability of the system to deliver the specified airflows. We'll also be looking at the drawings to verify that all of the necessary registers are in place and are also accessible. And also, we look at them to help the construction team determine where the tap contractor can take a traverse flow reading. So in an ideal case, and it can happen many times, the traverse flow reading is taken at just one spot for the supply and the exhaust. But we don't always have the luxury of that space, especially because we're in New York City, where we're trying to fit like so many apartments and so many things into tight spaces, right? So in this case, in those cases, the commissioning agent and the passive house provider were looking for like the least worst positions or locations for a traverse flow reading to be taken. So in this case, we're highlighting 2 different locations for the supply airflow to be measured and 2 different locations for the exhaust. And that's the case because on the floor directly above this, it's where the ERU sits and the ductwork just comes down directly vertically. So typically the traverse flow readings, they need to be taken in a location where there's like maybe 6 to 10 feet of straight ductwork, because we want to avoid having turbulence. But again, when we cannot do that, so we have to work with what we have. And it's not always ideal. It's like in this case, this superior marking, it's even after registers, which is definitely far from ideal. But yeah, it's the things that happen. And calling out these locations during the shop drawing phase is key, because we want to avoid finding ourselves in this situation where walls are closed up, ducts are protected with insulation and all that, and now we have to open them up to take the traverse flow reading. We want to avoid that. That's why we get involved and try to get coordination done as early as possible.
Yeah, and let's take a look at what we might see in the field too. And I think this is mostly common in we have a lot of projects across the tri-state too. Not only in New York City, we're also seeing projects in Massachusetts and Connecticut. These tend to be a bit smaller in scale, maybe 10 to 30 unit buildings. And what we've seen as part of the experience here has been, the image on the left. The ductwork layout looks great on paper. When we're dealing with wood frame structures, though, there tends to be a lot of conflicts both with the structural elements and with other trades, other mechanical, electrical, plumbing trades, sprinkler, fire protection. So even on smaller projects now, we're really making sure that the team is providing a detailed shop drawing that's going to indicate any kind of bends, extra elbows, turns in the duct that might add additional resistance to the system. And why is that? Right, at the end of the day, I have to come in and verify flow rates, and if there are 4 or 5 extra elbows in a particular duct run, we can actually have issues in achieving that flow rate at the end of the day, right? And at the end of the project. So this is something we've broken into our, our inspections, but also on, on the design side, requiring that shop drawings are, baked into the specifications for the project, despite the size. Now there's another photo here, if you transition, that's going to show the as-built condition. This is a great example. This has been since corrected, but this is a project we were recently on. And is showing the design here on the left. These are the ducts at the end of a corridor that are branching off into a few different apartments. And as you see in the design, there are this is all supposed to be 4-inch hard duct pipe, right? And what are we seeing in the field? We're seeing this sort of spaghetti work of flex duct used for over 6-foot lengths, no elbows. We have ducts that are tapped off the end of the main trunk and that are tapped off the side. And none of this is clearly shown in the design, and the shop drawings weren't provided here, and they just had moved ahead with business as usual, I suppose. And this was just a more recent experience, despite the specification being baked in there. We were still seeing this. So this is again since been corrected and coordinated with other trades, but it was a bit of some growing pains on this particular project. So I want to pivot here to a little bit slightly different but related topic, and that's duct sealing. I think I would hope that the high performance building community, we don't need to talk about basic measures of hand sealing ductwork. We really should be doing much better than just hand sealing on these high performing buildings. And I'm not promoting a particular product. I think we have just historically addressed reaching very low levels of duct leakage using an aerosolized sealant application. And this essentially seals ducts from the inside. And what happens is the ductwork system is capped off. It's sealed off, and a fan is used to pressurize the system and force an aerosolized particle throughout the ductwork. And so now those particles are finding all the leaks in the ducts and are sealing those up. But they really only seal up to about a 1/2-inch hole size here. And you can see the photo on the screen showing both the setup and what the before and after photo can look like. So this doesn't eliminate hand sealing. You still need to do, the HVAC contractor still has to do a good job at installing this and sealing it. But this is a particular situation we had here. Now, one other mention, there's really 2 ways to specify, in the design side, to specify duct leakage using this aerosolized application. One is based on the SMACNA standard. The other is this 3% fractional leakage method. So what I'm really pushing for, and I'm just going to make mention to, is this, and I'd be happy to expand on it later, is requiring that duct leakage is kept to 3%, and that's a 3% fraction of the total flow rate coming out of the ERV. So it's a very strict requirement, but it also helps balance both supply and exhaust. To have the same amount of duct leakage between its supply and exhaust, and that ends up assisting us when we get to the balancing phase of a project to make sure that the particular balancing requirements are met for the Pass-Fail standard. Pass-Fail requires that supply and exhaust flow rates be within 10% of each other. So if we have an imbalance in the actual way the ducts were sealed, it just further causes issues in the testing and balancing phase. So definitely have a lot more to say on this particular point, so we can perhaps talk about this later in the Q&A portion, but we'll keep it moving for now. And I want to point to another situation here. And these are purely just results from an actual project that had significant issues with duct leakage. And this was sort of before things were fixed, but we wanted to do an experiment and model the results we were seeing. So we're showing through our Fias-Woofy model comparison between design and construction. And really the comparison, all we have changed here is the duct leakage and the fan power for the ERV unit. There's only one unit on this project, and we can see about a 2.5 site EUI jump in total EUI of the building. So this actually can be significant and can actually, really change your modeling inputs and cause issues with compliance later on down the path if you didn't account for extremely high duct leakage, if you didn't account for this in design. So I think this is a great comparison, and everyone in the Passive House community would understand that these buildings were really drastically reducing space conditioning loads, heating and cooling loads. So now ventilation, especially if done incorrectly, as you're seeing here, can take up a larger chunk of that pie, of that energy pie, right? So that's what I wanted to highlight on this slide. Great, and there's a lot of values here shown, but really I just want to show you what's in red. This was a project that went very well, actually. We were able to get engaged with the project about 3 months in advance of the building getting turned over. We were able to do an analysis of duct leakage, reviewing all of the ERV units on this project. We had found issues. ERV3, for example, had over 32% system leakage. We were able to work with the contractor and with the testing and balancing contractor to reduce this duct leakage value. They actually reinstalled some aerosolized sealant, and they had done some other work to reduce by about 9%. And that was just from early engagement of Luis and I on site, being there early and able to see and get our eyes on this before the kind of push to get these buildings occupied. So this was also, just to make a mention, this was also make or break modeling input for this particular project. It was pursuing local incentives through NYSERDA here in New York State, and sort of the highest tier of incentives. And this was the difference by about roughly $300,000 for this particular owner. If we weren't able to address the duct leakage issues, they would have ended up bumping down a tier and losing out on about $300,000. So this was actually very significant for this particular project, but overall is a good result.
All right. So now shifting from ventilation and balancing, let's talk about controls that we see in the HVAC systems for passive house buildings. So passive house buildings, high performance, lots of top-notch edge technology, but I mean, we're definitely all for innovation, but we're also for sensible and realistic controls. So that's why from the issues that we have seen, the lessons that we have learned, we're now trying to have conversations during the design phase to have designers and developers think about who is going to run the building, what resources do they have, what kind of training will the building super have, and what type of building are we dealing with? Is it multifamily, is it institution, is it a large commercial groups? All these three groups are typically going to have different resources available for their O&M phase, right? And specifically for New York City in affordable housing, a lot of the passive house construction that we see here, these buildings have been having a high turnover rate of building supers, which means that the fella that receives the training at the beginning then moves on, and whoever comes next doesn't get the same kind of training. And again, the buildings here can have complicated systems in place. So let's go through an example here. So in this case, the intent was to have two ERUs connected to supply exhaust, to supply air and exhaust air with the same ductwork. So in this case, I'm just the highlighted is the supply, but on the left side, the unhighlighted is the exhaust. But yeah, they have that common ductwork, right? And they each have their own controllers, but the intent was to have a central controller that talks to it, but that central controller was a different manufacturer. So somebody else comes into the party here, and that adds another layer of complexity. So what was the first issue that we started noticing during commissioning? It's that there was a constant unlinking, disconnection between the central controller and the individual controllers of the ERUs. And every time that disconnection happened, which to this day, there's no clear answer why that was happening, the ERUs would fall out of balance. So all of the balancing and adjustment of set points needed to be redone. So time consuming. And again, if depending on who's doing the work and who's getting trained on it, when somebody else needs to do it, if they're not familiar, it can be time consuming and it can compromise the comfort level of tenants in the space. Additional minor issues related to this specific project was that this centralized controller was in metric units. And sure, like a lot of it can be said that it's easy to just look up what like conversion of liters per second to CFM, but typically building operators, they have a lot on their plate that it would be the easier that we can make it for them to operate their building and to sort out issues, the better. So like this minor thing can become a hurdle in an O&M phase. Additionally, the internal logic of the central control wasn't really clearly documented for troubleshooting in the field. So this was essentially a black box. What was the final solution for this project? After so many issues, disconnects, and having to rebalance and whatnot, between ownership, the design engineer, and the commissioning agent, we agreed that the best thing to do was stop using the centralized controller, just program the same set points on both ERUs, and have them run from their individual controls, making sure that each ERU supplies the same CFM to achieve the design intent. The downside of this is that, I mean, time and money went into like this controller and troubleshooting, purchasing, installing, and now it's not going to be used, right? So keep it super simple as much as possible, right? All right, and then another example of complicated controls and things that can go wrong in the field. Things typically go wrong in the commissioning phase or issues as are noted when we have different manufacturers having to interact with their equipment. So it is common that we have the ERU having to interact with a heat pump manufacturer, and that is being installed by a mechanical subcontractor. So we have 3 parties there, and the 3 of them need to figure out how to properly install this and what dip switches to adjust on each controller so that so the system works correctly, right? But if somebody purchases something that is set up from the factory, it is less likely that things are going to go wrong. When things have to be put together and wired in the field, it is more likely that things can go wrong. A lot of things can be missed, especially for newer technologies. So how do we avoid this? How do we make sure that ERVs are interlocked successfully with heat pumps for heating, cooling, and dehumidification? The first thing is from the very beginning, like when the contract documents are being put together, it must be clearly stated who's responsible for interlocking those pieces of equipment so that we avoid having issues that carry on until the occupancy phase of the building. Like in the coming slide, I'm going to show a graph showing some of the issues that we're having, that we're still working through them. And that we know that several buildings are having the exact same issue. So maybe a follow-up session will be like, this is how we address these issues for another PHA call or something like that, right? So yeah, it needs to be clearly stated who is responsible for adjusting them, and also how many site visits are we going to get from the manufacturer, the manufacturers to set this up, because these are pieces of equipment that one visit for startup and commissioning it's typically not enough, because we're dealing with the energy recovery wheel, the heat pump, the humidification, and all that. So it should at least have 3 site visits for like the different seasonal changes. Do some commissioning in the summer, do some commissioning in the winter, do some commissioning in the shoulder season, so that you make sure that the system has been adjusted to actually match the real building load. Because when miscommunication happens, when things fall through the cracks, when dip switches are not properly adjusted, we have an efficient system working terribly inefficient. So what is happening here? We have a bunch of cycling happening here. So the orange line is the supply air set point programmed into the ERV controller. And the blue line is the supply air as sensed by that temperature sensor in the supply ductwork. But what was actually happening? The theory is that when the ERV is sending a call for heating, because so the temperature starts dropping below set point, the heat pump takes a long time to react. And when it reacts, it overshoots. And it got to the point that eventually, instead of kicking the regulator, the heat regulator, it started kicking in the reheat control to supply heat. Now, for those who are not aware, hot gas reheat is something that is used for when we're doing dehumidification, so in the summer, not in the winter. But in this case, the dip switches were properly positioned, so the reheat was being used as the first phase of heating. So the heat pump takes a long time to respond. When it responds, it responds with the wrong coil, and then it overshoots the set point, and the cycle repeats over and over. What effect does that have in the building? We're supplying fresh air into all of these apartments, and a lot of tenants that have moved into these passive house buildings, they come from pre-war buildings that have radiators that are always on, and their apartment is always 120 degrees during the winter, and they're used to having the windows open in the winter. So in each of these drops of the curve of the graph that we're delivering close to 60-degree air, anybody who feels a breeze of 65-degree air, they're going to feel cold. And then they call the super, hey, I'm cold. And they do that often enough that the solution that a building ends up taking is changing this set point from 72 degrees to as high as possible, which typically is like 84 in this type of ERV. But that doesn't really fix the issue, right? Because we're still gonna have the cycling. Right, yeah, so that's like the key thing, and this is something that we have been seeing in several of our passive house buildings, and again that we're still figuring out, because as the commissioning agent, we end up being like the person that bridges the gap between the different stakeholders, because when we see issues and we call out issues, several times it can become a finger pointing argument, right? So it becomes our job to like, all right, let's just transfer information and try to get this through the finish line. So yeah, how can we avoid this type of issues? We should have clear and realistic sequences of operation, which means that the commissioning agent should be involved early in the design phase to do design reviews, have clear defined roles, as I mentioned, between the installer, the supplier, the manufacturer, and the commissioning agent, so that all the communication, nothing falls through the cracks, and it is clear who's responsible for programming and wiring and adjusting. And yeah, having clear expectation, like when is the job actually done? When do we actually say to the installing contractor, all right, the job is done, this thing is working the way that it's supposed to. And also having clear, something that is key is warranty periods. Like a lot of times the warranty periods are like as soon as the startup is done, but we typically recommend that the warranty period doesn't begin until startup, commissioning, functional testing has been completely clear, and there are no issues. That way, we have some time to address anything that may come up during the first years of operation. And yeah, and to make sure that this, like whatever gets done, adjusted, implemented in the commissioning phase of the building, so it carries on to the operations phase, we need to have proper training in place for our building supers, our building operators. Like these folks, they are basically the first line of defense in our buildings to make sure that they continue to run as efficiently as it was intended. So they need to have the tools to succeed in managing their building. We need to teach them to look for things that may be wrong and when to look for it, teach them how to diagnose and solve problems, and also identify, like help them identify when they can solve a problem and when it is necessary to call out technicians. And something that is definitely key, but sadly doesn't happen all the time, is that these trainings that these folks receive, they should always be recorded. Additionally, for ongoing commissioning, ongoing commissioning and monitoring is something that is key in the first few years in the operation of these high performance buildings. Because of what I mentioned earlier, like the first 3 years, the building is going through different seasons and the equipment is going to react differently, and we're actually going to see, are we getting a comfortable space with what we have? And Yeah, I already mentioned that at least 3 or more site visits are necessary to properly commission the systems that are an ERV hooked up with a heat pump. Back to you, Mike.
Great, thank you, Luis. And I think in conclusion here, I think we bring these topics up at presentations and to the wider audience and Passive House community because in a lot of ways, I think the gap between design and construction have been bridged. We do see some great architects and engineers who really understand all that encompasses Passive House. We are seeing contractors that are becoming experienced with it. If you transition here, Luis, we need to start thinking more about this last piece, right? Bridging between construction and operations, and what does that process look like beyond just getting Passive House certification? I think it's everyone's role and responsibility at the beginning of projects to think more broadly about things that Luis had brought up. Who's going to be operating this building, and how are we actually going to maintain the efficiency that we've designed through construction and then into operation. So I think in some ways we're still bridging this gap, and that's the message I think we want to leave off with. So we'll end it there and take any questions.
Thank you so much, Michael and Luis. This is such a good reminder, and this last slide kind of summarizes it so beautifully. I feel like that meme that you had, Luis, first up from the design versus shop drawings versus as built. There's like a fourth character, which is how the building operates, right?
Hi, I'd like to give a big thank you to the fine organizations that make our work at Passive House Accelerator possible. First, a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you too to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Bewiso, Icon Windows and Doors, Intelligent Membranes, Proseco, and Source 2050. And thank you to our patron sponsors, Brennan, Coltraco Ultrasonics, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you, sponsors.
Yes, thank you, sponsors. We certainly have a lot of really good questions that we're excited to have you all ask or have us ask if you can't.
I'm kind of old school. I'm a Passive House certified tradesman from the first class in Ireland. And 475 building used to be my tenant on Union Street in Brooklyn. So I know a lot of those guys early on, and I built multiple Passive House projects in New York City, from single family homes to multifamily condominiums and office buildings. We never got any of them certified, but they all work correctly because I look at the electric bills and everything. So it is what it is. And I also property manage some of these condominiums as Passive House. So it was interesting questions that you guys were asking. I just put one thing up there when you got into HRVs and ERVs. And these are the answers we couldn't get answered back in 2010 and 2009 about if you're doing ERVs, which basically is an energy recovery as opposed to heat recovery, and it captures molecules like water molecules and saves those and retains them. The question I had when I was listening to these presentations back in 2010 and 2009, what other molecules do they capture? And what other molecules do they actually compound within the living space? It could be VOCs. I said, what about VOCs? What about arsenic? What about anything else that off gases from whatever your final consumer is going to be for that space brings into their living space, and it starts off gassing stuff, and it gets compounded into the living space, even though you have this great air handler where it changes the air 3 times per hour, and there's no microdust. I really have a pretty decent knowledge of this stuff from the ground. I was also a general contractor for the last 20 years doing this in New York City. So these are the questions I have. And I went to Build New York, and I found one item. I found 3 items that were like Passive House, like would be good for Passive House. And one of them was for a big commercial building for actually removing VOCs and such chemicals. And I posted in the comments when somebody else was asking me about it. So, I mean, I'm looking at it from a slightly different perspective, but I just, wanted to say thanks for including me. And that it was just, VOCs and other molecules, because you don't know what the consumer is going to bring into their space. And it's, so, and I've dealt with it because, like I said, I've dealt with condominiums that are passive, that they have brought really crazy things into the space. And and these aren't large buildings. These are 10 unit and under buildings that we've built. And we did individual HVRs for each unit. And we had to do a crazy manifold solution with cassette heat pumps because there was nothing small enough to individually heat and cool a unit. So it just, I like the change that I've seen when I went to build New York, 10 years later, looking at the products that were there, or a lot of them weren't, but it's getting better. And I'm very excited for everybody else that's building passive now. Of course, it's a lot easier than when it was when we were doing it, because we just did stuff that nobody else knew would work or not. So enough of me, I'll mute myself. I'm sorry, guys.
Thanks for your question, Bill. I think you bring up a valid point. When I think about these larger buildings that we're seeing with larger rooftop units, energy recovery ventilators that have a rotary core, it applies to the other systems as well. But really those airstreams, supply and exhaust, they never actually touch. There's never actually a transfer of airstreams. Those remain independent of each other. So any VOCs in one airstream are exhausted, and likewise. Through the core, right, we're actually just exchanging heat and as you mentioned, latent the moisture. Just to another point, all these units are coming from the factory now with MERV 13 filters that we're seeing on both supply and exhaust streams. So they're capable of capturing, very fine particulates, micron sizes, including, things like the coronavirus and other airborne diseases. So,
Am I still muted? Michael, I understand how EVRs and HVRs work, and I understand that it's a multi-sided ceramic filter that allows you to do the heat exchange. I understand all that. I am telling you, you're saving water molecules. If you're saving water molecules, those are transferring back into your new inbound air from the exhaust air system. There is an actual transfer there. Okay, I have a science background. I'm just telling you, there's a transfer there. So transferring water molecules, something else can transfer. And I'm asking, how do you know what's transferring? And I couldn't get a good answer for that. I'm not asking you for an answer. I'm saying this is a good question. You should be asking somebody at a manufacturing level. Okay, I'm not trying to put you on the spot. The only thing I saw at Build New York that was somewhat interesting was, and I posted in the chat, was where is it? I can't even find it right now. Enver, and I gave the website and everything else, and that was meant for a small commercial application that would actually take the waste, the recirculating air. They were just recirculating air in the building. I said, this would be great for passive applications, and the guy didn't know what I was talking about. But I said, that's okay. Let me just take your equipment and we'll make it work for what we need to make it work for. But it's just something you should look at because I found it really interesting. That's all. And we could talk about trying to do heat recovery from wastewater. I mean, I've done some really crazy stuff with the guys in Europe, and we talked at 475. If you talk to anybody at 475, mention my name, they'll start laughing. Because it was, we were all there at the same time, trying to learn how to walk and run and everything else. But
Bill, I'm gonna cut you off here. I don't mean to. I think we really appreciate this question, and thank you for clarifying, what you're asking here. I want to make sure we're asking this in a way that we all feel good about here. But so what I'm getting from this question is, maybe this isn't a question that our presenters here can fully answer, but if you're transferring water molecules, what is bound up in that? And can we, is there a way to, limit any harmful molecules and materials that are included in that?
That's all. Have a great day, guys.
No, thank you. This is a great question.
And it's a good segue on not related to the water molecule side, but on the air side. Steve had asked, how likely is it that air in one apartment will enter another apartment? And Michael, you sort of answered that in the sense that at least exhaust and supply are isolated in the ductwork, but he's asking how can it be prevented or remediated? And that's in the context of centralized ERVs, but I think there's also other things to talk about there from a compartmentalization and air transfer standpoint.
Yeah, it's a great question. Yeah, I think sealing the ductwork is also an impact there. Well-sealed ductwork, we really should not have much transfer at all between apartments. And to take Carmel's point to another step here, the compartmentalization requirements, particularly for the Passive House US standard, right, is requiring that those apartments are compartmentalized, are air sealed between them and the corridor, between them and other apartments, in order to limit any air transfer between those. You know, the doors are gasketed, any penetrations or plumbing, MEP related penetrations between units are sealed. So air transfer, now we shouldn't see it. And actually PHI, so this is the international standard, when they certify ERV units, HRV units, they actually look at cross stream contamination, so between supply and exhaust. And one of the hard requirements in their factory testing is a 3% leakage or less. So any PHI or Passive House International certified unit will come with that kind of guarantee that you won't have cross stream contamination at the unit itself. So.
Awesome, thanks for that. And next up we have Tom Phillips, if you can unmute. And if not, we're happy to ask your question. Give you another second. All right. So Tom was asking regarding HRV operation and maintenance problems, what are city and state requirements for filter changes and for periodic commissioning or constant monitoring?
I'm not aware of city and state requiring anything specific for how often a filter should be changed. Every 1 to 3 months typically is how often the filter should be changed, but that varies depending on the location of your building, what kind of pollutants are around. What was the second part of the question, Carmel?
Periodic commissioning or constant monitoring requirements.
Right. Yeah. So that definitely not from city or state. If the building were to also do lead enhanced commissioning, that program has an option to do a credit for monitoring based commissioning, which it's great because we're able to see some data of real operation when the building is occupied. But at the moment, there's no city or state requirement to have monitoring based commissioning in the projects that we work on.
A great question, nonetheless. It sounds like Armin can't unmute. So Zoe, did you want to ask his question for him?
Sure. Yeah, thank you, Armin, for this question. The question is, what are some tips to help ensure better craftsmanship from contractors in the ductwork installation and sealing? And what do you say and when to avoid offending or scaring them? So this was answered in a couple different ways by different folks in the chat, but I think it would be great to get both of your feedback on this as well. Yeah,
my approach from what I learned my early days in the industry is typically approach an installing contractor with a question before trying to say like, oh, this looks wrong. Like ask them what is their process, try to get a conversation going, try to build some rapport with them. Mike and I are aware that sometimes when we show up in the field, we're not everybody's favorite person. Like here's Swa to ruin my day, having redo work, and we want to avoid it. But I mean, I also think that if you haven't pissed off a few people, maybe you're not doing the job all the way right, you know? But yeah, I mean, asking them the question, and like once they tell you the process, like, all right, like, well, how about this? Like, because let's say they tell me like, well, you know, I assemble the ductwork and I put it up in the ceiling, and then I do the mastic. Like, okay, well, what about the edges that are tied against the ceiling and you cannot seal them anymore? Well, they try to tell you, like, they try to explain to you how they do it, and like maybe you can suggest, well, how about maybe you try to do the mastic before putting the ductwork up against the ceiling, and yeah, maybe they're receptive to it. Maybe they change course, but also we need to keep in mind that construction is booming, and there's a lot of jobs that these folks need to get through, and folks are trying to get to the next job as quickly as possible. We also have a challenge with skilled labor available. So there's a lot of things, there's a lot of different challenges. So it's, to wrap up the actual question, ask the question, try to build rapport, try to understand the process, based on the process, make suggestions, take it as far as you can before trying to tell people what they should be doing.
Great, thank you. And I want to ask a related question here. How do you make sure that you get on site at the times when, say, like the balancing contractor is there, or whoever else, you need to be on site with? What's that coordination like, and how do you begin that coordination?
Michael?
Sure, I can take that one. First off, we're always requiring the balancing procedures, like the strategy, the approach, to be submitted through a formal process that is going to get reviewed. That's going to key us in that balancing is going to start soon. And then we're making comments that we need to have a meeting about those procedures with the tab contractor before they step foot in the building. So that ends up building a chain of communication with them and understanding who it is, who's been contracted, because we typically see this done towards the end of the later stages of the project. And lastly, so it could be a challenge to coordinate getting on site with them at the same time, but that's often also required. We'll sit down in the meeting, we'll discuss the procedure, and then we'll say, okay, when is this starting? If it's Tuesday, we'll be there on Tuesday to make sure you're using the correct flow measurement unit and some of those things. But in general, we're seeing, at least in New York, some more advanced balancing professionals that are really kind of taking the reins on and actually working on many of our past house projects. So they actually really get it and understand our angle on it also. So
before he hops off, and that is what's next for the future of Passive House? And Luis, you don't have to be the first to answer that. Michael, you can take it first. Up to you guys. I
can jump in while Luis ponders this one. I think I'd like to see more of an emphasis on the commissioning side, actually. I think it's in order to get these buildings to work correctly and to have the durability and longevity that that Passive House touts, we need to see some focus on some of these post-occupancy studies and surveys, and understanding better how they're performing after the plaque goes up at the entrance to the building, right? It tends to be just an effort to get certified, and sometimes we see that focus lessen once that plaque goes up. So that would be my 2 cents on that question.
Yeah, hopefully for the future of Passive House buildings that typically have VRF systems for their apartments, in the future, I would like to see not so oversized systems that sacrifice COP so much, but that's something that will need data to back up our recommendation to reduce the size of equipment, so that we convince design engineers that they won't be getting in trouble for not providing the right amount of heating or cooling. But I'm sure there's some work in progress on that end, and also something way more granular, like at the each apartment level, is the way that we install grills or diffusers for fresh air into the apartments, that in the future we think about how do we distribute that air, minimizing the effect on the tenant. We want to make sure that they have fresh air, right? But again, if somebody feels a 72-degree breeze over their skin, they're going to feel cold. They're going to complain, and that can trigger somebody changing the energy efficiency recommendations that a consultant provided from like 72-degree air supply air set point to 85 because my 125 tenants keep saying that I'm cold. If we make sure that it's part of the process, that air does not blow down, but I don't know, just upwards or something that the tenant doesn't feel it, that can also help avoid some of these issues. And hopefully that's something that we start implementing in future projects.
Perfect. Thank you. I like those answers a lot. Pretty unique. So I guess with respect for your time, Luis, thank you so much for joining. Feel free to stay with us if you can, but if not, we definitely understand. Thank you so much for this very cool, different type of presentation from a different perspective. So I think it's really valuable for all of us. There are obviously great questions about it, so really appreciated. We want to, if in case others have to go as well, we want to introduce what next month's Next Gen program will hold in store. So we will have Kara Haggerty Wilson, who is a project manager at Onion Flats Architecture. Specific presentation to be announced later. And with that, I think we'll continue with questions for as long as you guys, and maybe Michael in particular, can keep joining us. So our next question on deck, I believe, is from Jeff Light. Okay, the quick question from Jeff was, it's all open BACnet with some with the same protocols, correct?
That's a Luis question. I do think that is accurate, but that would be a Luis question.
Good timing. Probably, but maybe we'll get that to Luis later. Okay, next we have Bev Craig. Do you want to unmute?
It looks like Bev just left.
Oh, and she did have a great question that was answered and chatted about in the chat regarding, the specific product of the aerosolized solution, AeroSeal. Michael, do you want to talk a little bit about that? And also, I had a follow-on question selfishly to that, which is if you've seen jobs that can actually hit the 3% fractional leakage without the use of AeroSeal or a similar product.
Yeah, both great questions. Yeah, so Bev wanted to know if there were other manufacturers besides AeroSeal, and I do not know of any. At this point, at least, there aren't any direct competitors to that proprietary software and technology solution. One thing I mentioned in the chat where that can really come in to be a problem is some projects, particularly institutional or state buildings, cannot have like a sole source, building specification in the project manual. So in that case, we've been specifying just the performance targets and not requiring the aerosolized application. But to your question, Carmel, I have not seen 3% leakage hit on any building ever, and I've looked at a lot of data in that regard, and I think hand sealing procedures are completely inadequate to reach this level of air tightness. I think you could get close to 10% with some very good hand sealing procedure, but I've seen really good hand sealing done. A contractor was very prideful and claimed that their ducts could hold water, and they had done duct leakage testing to see if they needed AeroSeal, and that project came in at about 20% duct leakage, and it actually looked very good. I had inspected it; it was very good quality. So that's been the experience there. You can likely get lower with some of these smaller. If you do individual ERVs, you can likely get to hit lower targets. But yeah, hope that answers everything.
They've got the market cornered in that aspect. Up next, we have Tom Phillips again. You had a second question regarding range hoods, if you're still with us. And I don't think he unmuted the first time, so I'm happy to ask it. How are range hoods ventilated, direct exhaust, or motorless hood vented through HRV or ERV with the pre-filter for grease?
Sure. So we've at least the historic context for our projects, large scale multifamily, has been we're ducting exhaust air to the kitchen area, approximately 6 feet from the stovetop, and that's filtered using usually a MERV3 filter for the FIAS requirement. But yeah, the actual range hood itself, we've been using carbon filtered recirculation hoods, at least in the context of New York City. We have seen some other strategies, but that's been the majority of the projects we've seen.
All right, I know there are lots of opinions on recirculating range hoods, but we're gonna leave that conversation to another context because it's definitely discussed elsewhere. So let's get to the next question. It's from the eCode team. Whoever is representing that, are you able to unmute yourself?
I can. I'm just curious, between the different passive house rating systems, between PHI and FIAS, what's the difference in the QA, QC? How does commissioning vary between those two groups?
Very, very good question. FIAS, the US standard here in North America, they are requiring the passive house field verifier to verify flow rates within the apartments themselves. As I mentioned earlier, 10% of the apartments. We're also required to verify overall flow rates of the ventilation unit. So that could be, that's a physical measurement typically though. So it's either coming from we're there with the balancer, or in individual ERVs, we're actually taking that measurement. And those and watts per CFM. So that's the next piece. Is fan energy, the watt per CFM of the ERV, HRV unit. Those are all modeling inputs that get translated through the PS workbook and then translated into the final energy model for certification. So it's much more rigorous than what I'll talk about now, which is the PHI standard. The PHI standard has allowed, essentially the only verification we need to do is of the actual flow rates that are introduced into the building. And those are translated back into our energy model. Now, fan energy, at least our team's perspective, has always been to verify fan energy and use the actual field verified fan energy value in our energy model. But I've heard lately that PHI is actually not requiring that in their modeling for certification. I personally think that that should be a verified model across all standards, but that is just my own opinion, and that is just something that we hold an internal standard.
I'm going to ask a question that Zoe posed related to this, and that's what do you do if the ERV wattage is too high for what you've modeled or the threshold? Are there any remedial steps to lower and get a better efficiency on the unit?
Yeah, that's an excellent question. And honestly, with our well-sealed duct systems, we're not seeing high fan wattage. Actually, we're seeing slightly lower fan wattage in many cases, which works out well. But in the event that we have extra duct leakage, that can be an issue. One of the things our team has been doing is holding conservative values for both fan energy and for overall flow rates. We're assuming sort of 10% duct leakage, just a worst case scenario in our design model. That way, when we get to final construction, there's no surprises like, oh, there was higher duct leakage, there's higher fan wattage, and it can really be the make or break between a project. We had some projects that that were designed many, many years ago, early on in this, that we're actually much tighter on these thresholds. So that's been our approach.
Yeah, that was actually kind of my experience and approach as a CPHC too. But what's interesting is sometimes if you overestimate the wattage or the duct leakage and it turns out to be less than you expect, there can be downstream effects on heating or cooling that you didn't really expect. So it's a little bit of a balancing act.
Yeah, absolutely. That's a great point though.
I think maybe we have room for one more question. You said 110, right?
Yeah, 110.
Yeah. Great. Armen had another question, and I believe they still cannot unmute. So, Mike, does this mean that we? So this was in relation to the aerosolized sealing. Does this mean that we have to ensure good hand sealing and use aerosol to ensure 3% maximum
Exactly. That's exactly correct. As I noted, the aero seal can only seal up to about a half an inch, and you'd be surprised at what you can see in the field that are gaps that are larger than sorry, did I say 1%. A half an inch is the size of an opening that aero seal can actually fill. So you'd be very surprised at how many openings are in ducts that are more than that. And I think it also depends on the particular duct construction, but yes, we're pushing for both, absolutely.
Thanks so much, Michael. Appreciate the time and the presentation. And like Zoe said, this perspective of, the final state of a building as it operates and how to get there from very early on in design. Looking forward to continuing these very interesting conversations that we've had both live and in the chat. And yeah, thank you everyone for joining, and we hope to see you next month for Kara with Onion Flats Architecture.
Yeah, thank you for the invite, and thank you everyone for joining.
Thanks everyone so much. This is great.